In other words, we just do medical research. That's all we do. We just do medicine. And yes, if we are successful, then we will have a big side effect in terms of how long people will live. But we should be concentrating on the completely uncontroversial fact that we will be extending how long people can remain healthy. Nobody wants to be sick, and that's all we're working on. So, how big will the side effect be? Well, I believe that the therapies I am telling you about today will give a few decades of extra life, that we will be able to let people be at the age of 90 who are as healthy as people are today at the age of 60. And, you know, that's wonderful. That's really good. But that doesn't tell you how people are going to live to 1,000. And that's true. I do not think that the therapies we are working on today will actually let people live to 1,000. So what's the catch? How do I talk about people living to 1,000 who are already alive today? Well, really it's because these therapies are rejuvenation therapies. If you take someone who is 60 and you slow down their aging clock, supposing you could actually do this thing that I told you was impossible, slow down the creation of damage. And that's good, but it's not all that good, because they will still be getting biologically older. And eventually they will get sick anyway. That means that therapies like that, even if we could create them, they would only be useful, they would only have a big effect if they were initiated early in life. But rejuvenation therapy isn't like that. Rejuvenation therapies turn back the aging clock. They make people biologically younger again. So if we take someone who is 60 and we give them these therapies, they become biologically 30 again. And it's because of that that they will have the chance to live until they are 90 before they become biologically 60 for the second time. Now, the thing is, it takes 30 years to become 90 if you start off being 60. And that's a very long time in technology, including, of course, medical technology. So if somebody comes back at the age of 90 and they need to be re-rejuvenated, they need to have their aging clock turned backwards again, if we were to give them the same therapies that they had 30 years ago, it wouldn't work. Those therapies will have done all they can do. But they won't be the same therapies anymore. We will have version 2.0 that has benefited from 30 more years of research, which means that we will be able to re-rejuvenate these people so that they will not be biologically 60 for the third time until they are maybe 150. And that's what I call longevity escape velocity. If we can just improve the comprehensiveness of these maintenance therapies fast enough that we can stay one step ahead of the problem, then we will have the same indefinite postponement of pathologies of old age that we would have had if we had had completely 100% perfect maintenance therapies from the beginning. So of course the question then is, how rapidly is that? Many of you have probably heard of the singularity, the idea that computers will become more powerful at an accelerating rate so that eventually they will be almost infinitely powerful. And you know, people think, well, maybe that's the same kind of idea, but it's not. And it's important to remember that it's not, because the singularity doesn't really work for biology, for medical research. There is no reason to believe that our power to do medicine will increase at a rapidly accelerating rate. Luckily, however, for longevity escape velocity, we don't need that. We don't need medical progress to happen even at a constant rate. It's okay for it to slow down a little bit, and it's still good enough. We still stay one step ahead of the problem because, of course, the more comprehensive the therapies become, the longer it takes for the remaining damage that we still can't fix to reach a threshold of pathology. So that's why longevity escape velocity is very realistic.